Hello everyone. I will be explaining Dijkstra's single source shortest path algorithm in this video. Dijkstra's single source shortest path algorithm is an example to single source shortest path problem which we have discussed in the previous session. Given a weighted graph, the objective is to find the shortest path from the starting vertex or the source vertex to all the other vertices in the graph. Now in this case, when a graph is given, you may consider any of the vertex as your starting vertex. And since we are finding the shortest path, or the objective is to find the shortest path, we can conclude that it is a minimization problem. That is, in turn, it is an optimization problem, and optimization problem can be solved using greedy method. We have already discussed about greedy method, wherein it says that the problem should be solved in stages, taking one step at a time and considering one input at a time. And there are predefined procedures and defined in the greedy method, and it has to be followed to get an optimal solution. So in this particular video, we will take a small graph, a very simple graph, and try to find the shortest path from the single source to all the other vertices of the graph. Now here you should notice that the relaxation is done with respect to the vertex using this formula given here, that is, if distance of u plus cost of u comma v is less than distance of v is relaxed to distance of u plus c of u comma v. One thing to be understood, the meaning of relaxation is you are finding a path from the source vertex or from u to v which has less distance than whatever distance currently allotted to that vertex. So we'll come to know about it when we solve this problem. Now here there are three vertices given, and there is a path from 1 to 2, and there is a path from 2 to 3, and also there is a path from 1 to 3. The cost of each edge is given here, that is cost of 1 to 2 is 20, 2 to 3 is 10, and cost from 1 to 3 is 40. Okay, and let us consider 1 as a source vertex. Let us assume my source vertex is 1. Now what is my objective with respect to this algorithm? I need to find the shortest path from the source vertex to all the other vertices in the graph. Okay, so let me assume 1 as source. So according to the single source shortest path algorithm, which we have already discussed in the previous session, the first step is assign the distance of u, that is our source vertex distance, as 0. Why is that we are assigning it as 0? Because 1 is our source vertex and we are finding the distance of 1 from 1. The distance of 1 from 1 is 0. So we are assigning the distance of the initial source vertex as 0. As well as all the other vertices, we are assigning a distance as infinity, because initially we don't know what is the distance of these nodes from the source node. So let us do that first. We have assigned the distance of 1 to 1 is 0, and since we don't know what is the distance from 1 to 2 as well as from 1 to 3, we have assigned it as infinity. Now we should go for the relaxation. That is, since our source vertex is 1, we should find all those edges that is coming out from 1 and check whether I can get a path from 1 to the edge that is connecting from 1 to the vertex that is connecting from 1 with a shorter distance. So let us start with the first vertex, that is 2, that is 1 to 2. Let us find, is there a shorter path which has a distance less than infinity. So in this case, when we are considering 1 and 2, 1 is our u and 2 is our v. So this is my u and this is my v. And we already know that distance of u, that is distance of the source vertex, is 0. Distance of v we have assigned infinity. Now let us try to relax. So what is that we have to check? If d of u is 0 here, plus cost of u comma v, cost of u comma v is given as 20. So 0 plus 20 is less than d of v. D of v is infinity. So 0 plus 20 is 20. 20 is less than infinity. If that is the case, what is that we have to do? We have to replace d of v as d of u plus c of u comma v. D of u is 0. C of u comma v is 20. So 0 plus 20 is 20. So the new value of d of v is 20. So from infinity, it is getting changed to 20. So we have found a path which is, the distance of which is 20 from D of U. Okay. Now we had two edges which is coming out from 1. One was this edge to the vertex 2. So we have found the distance of V from the source vertex is 20. Now let us find the next edge. Next edge is connected to the vertex 3. As of now, the distance of V, when we considering this particular edge, my U is 1, that is a source vertex, my V is 3, right? And D of V is infinity here, D of U is 0. Okay, let us see that here. This is my U, this is my V, D of V is infinity, D of U is 0. Again, I'll try relaxing. So I'll check if D of U, that is 0, plus cost of U comma V. This is my U, this is my V. What is the cost? Cost is 40. So 0 plus 40 is less than D of V. D of V is given as infinity. If it is lesser in this case because 0 plus 40 is less than infinity. If it is lesser, what is that I have to do? I have to replace D of V as D of U, D of U plus C of U comma V. D of U is 0, C of U comma V is 40, 0 plus 40 is 40, so infinity is replaced by 40. So I've got a new distance as 40 from 1 to 3. Now I have finished checking with 1. There are two edges from 1. I have completed that. 1, I got a distance as 20 here for the node which is represented as 2, and the vertex with 3 I've got 40. Now I will check which is a smaller value. 20 and 40, smaller value is 20. So let us see if there is an edge which is coming out from 20. There is an edge which is coming out from 20, that is to V. So in this case, this is my source, this is my destination. So this is my U, this is my V, and D of U we know it is 20, D of V we know it is 40. Now let us try relaxing. We are finding whether there is a path which is shorter than the distance which is mentioned here, that is 40. Now let's check if D of U is 20 plus cost of U comma V, cost of U comma V is 10. So 20 plus 10, if it is less than D of V given here is 40. That is, if 20 plus 10 is less than 40, in this case it is true, it is less than 40. How do we relax? We replace the value of D of V as D of U plus C of U comma V. That is 20 plus 10, that is 30. So 40 is changed to 30. Now we have tried all the edges. So finally I have the distance from 1 to 2 is 20, shortest distance, and distance from 1 to 3 is shortest distance is 30, because I have one more path here which has a cost of 40, but less than that I get if I travel from 1 to 2 with a cost 20 and 2 to 3 with a cost 10. Total is 20 plus 10, 30. So I can conclude it by saying that the value, I can put it in a tabular format and then say if the source vertex is 1, to the vertex 2 the distance is 20, to the vertex 3 the distance is 30. Okay, I should have entered here. I'll just add this. Yeah, the shortest distance to 3 is 30, shortest distance to 2 is 20. From where? From the source. So herein I'm trying to compute the shortest distance from the source to all the other vertex using Dijkstra's single source shortest path algorithm. Now you have another way of doing this. Yeah, it's given here. Okay, there's another method of doing this wherein I can ignore the first step. That is, if I'm considering 1 as my source node, directly instead of applying infinity to all the nodes, directly I can give all the edges that is coming out of 0 its cost. So I can say the cost of this particular node, because there is an edge from 1 to 2, the cost of this is 20. The cost directly I can write, and there is one more node from here to here, so the cost I can write it as 40 directly. So first step can be ignored, wherein I'm calculating with infinity, can be ignored if required, if the graph is uh, very complicated graph. The first step you may ignore it, wherein the cost which is for all the edges which is coming out from the source vertex, you can replace it with the cost, and then you can find the cost of remaining vertex. Okay, so That's it for today's video, and thank you so much for thank you so much for listening to this video. Hope you understood the concept.